Hi, folks. Gonna do a little math here. Math never hurt anyone. Okay, number 85 here in this section. We're told that f is continuous, and we're given this information about an integral. The integral from 0 to 4 of f of x dx is equal to 10. And so when you see this symbolism right here, maybe it's nice if you could just have a picture pop into your head. So what they're saying is the area, you don't know what the function looks like, but you're free to just pick whatever you want. So just make it a little squiggle here. There's f, and what it's saying is that if we go from 0 to 4, this area here is 10. And it could be something different where the function goes below the x-axis or something, but just have something pop into your head is helpful. Your brain kind of likes visuals. So that's what that means. Okay. Now what they're saying is to find the integral from 0 to 2 of f of 2x dx. Okay, well, uh, how are these related? Now it's going from 0 to 2, okay, but it's not f of x anymore, it's f of 2x. So you see f of 2x goes twice as fast. By the time x gets to 2, we're really at 4, f of 4. So this 2x goes more quickly. Now to compare it to this, obviously they give us this information right here. So we're going to have to use that in order to find this integral that they want. Okay, and the design, and they even prompt you to do this, but make a u substitution for this. And here's a concept that we're going to use over and over again, is that when you have an integral and you have some variable and it goes from, doesn't matter, from a to b, that's equal to the integral from a to b of f of x dx. It's just changing the variable. If you had, I mean, you could put Mickey Mouse in there. It could be f of Mickey Mouse from a to b. That would also be the same. It doesn't matter. And we're going to be playing this trick where we're going to be going back and forth between u and x, and it's going to feel a little suspicious, I think. As the youth would say, sus. Okay, we're going to follow their directions, though. And we're going to let u equal 2x, and then we have to substitute for everything we see up here in this integral. Okay, so we're going to need dx. The way to get dx involved is to take the derivative implicitly on each side here. When I do the derivative of u, I get du. The derivative of 2x, we get 2 dx. Okay, and then from that, I'm gonna get that dx is equal to 1/2 du. I solve for dx there, and I'm gonna put that right here when I convert this. Okay, now the 2x part, that's equal to u. Okay, so let's convert this integral. We have f, it was 2x, but 2x is equal to u, so it's f of u. And then dx is now 1/2 du. I'm going to put the du here, I'll put the 1/2 out here, and we still have the bounds of the integral to deal with. Okay, so just be real methodical about this. When x is equal to 0 up here, then that means that u is equal to 0 also, because u is equal to 2x. Okay, so then when x is equal to 2, then u is equal to 4, because I'm plugging it into the u equals 2x here. So when I put my bounds in, now that I've converted it to u, I'm going to have 0 to 4 here, because u is going from 0 to 4. Okay, and then see, now we're going to use that trick I mentioned over here. This is the same as if I had an x here, so that's equal to 1/2 0 to 4 f of x dx, because it doesn't matter whether I have u or x or Mickey Mouse. But this part right here, we're told, is 10. So this is equal to 1/2 times 10, which is 5. So that's the answer to this integral here. Let's do number 86. 86, same kind of thing. We're given an integral. Maybe picture the area. So that's an area of 4. A little quick sketch. That's from 0 to 9. We've got some f of x from 0 to 9. That area is, so this is 9, and this area 4. That's the picture. You don't necessarily have to write it down, but I'm doing it for you. But you can just have a visual for that symbolism, because otherwise you're just looking at it and not really sure what to think about it, right? It's just symbolism. Okay, but that's what it means. That's how to interpret it. Now, what we want to do here is find this integral. 0 to 3 x f of x squared dx. And you might be saying, well, why would I want to do that? And I think the answer to that question is you wouldn't, except that it's in this book and they're asking you to. So when you have that feeling when it comes to math, the way I always approach that is it's just like a little puzzle, it's a little challenge. See if we can mentally negotiate this maze and get to the answer, but it doesn't necessarily have this practical meaning. It's just good for your mind to try to play around with the definitions and things. Okay, anyway, let's keep going. It's got to be related to this one because otherwise they wouldn't give it to you. So let's do that same thing that we did before. Let's do u equals x squared because I want to get it in the form of f of u, right? And it's a little innuendo there. But u equals x squared, and then we have to substitute for everything we see here. So when I do the derivative of u, I get du. The derivative of x squared is 2x dx. And that's perfect because in this integral they're asking me to find, I have an x dx, and that's present right here. So I'm going to immediately say that x dx is 1/2 du. We've got the same kind of thing unfolding that we had in number 85. Okay, so now I'm going to be able to substitute for everything there. I haven't found the bounds yet. Let's do that. When x is equal to 0, u is equal to what? Well, I'm using u equals x squared here. So u is equal to 0. And when x equals 3, you see these are the x bounds here that I'm plugging in. And then when I plug in x equals to 3, I get u equals 9. And I didn't write that as a u, so I'll just change that real quick. So now we're ready to go with our integral. We're going to convert this integral into, it'll be the integral. Now u is going from 0 to 9. F of x squared is now f of u. Then the dx, the x dx, this part right here, that is going to be 1/2 du. We'll put the du here, we'll put the 1/2 out front. And see how this little entity here is the same as this entity here, even though one has an x and one has a u, they really represent the same number, the same area. Okay, so that's equal to 1/2 times 4, because this is 1/2 integral 0 to 9 of f of x dx. All right, so then the answer is 2. Okay, I knocked a couple out there. That's pretty good. Let's keep going. We're going to do how about number 87 next? Okay, so integral of a to b of f of negative x dx is equal to the integral of negative b to negative a f of x dx. Now, just observe yourself when you look at that. Hopefully you're following along in the book and you can get a better version of it. But when you look at the symbolism, just look at how it just kind of jumbles your brain a little bit. Okay, but that's not. It's not about looking at this and just seeing the whole thing unfold before your eyes. We're going to pick away at it and we're going to show what they want us to show, and we're going to draw a little picture of it too. All right. So Um, if we're going to do the picture, they ask us to do the picture in the directions. All right, so typically A and B are going to be positive things. So let's just put A and B in. Okay, and then if those are A and B, well, then negative A will be here and negative B will be there. Okay, so that's where those things are on the x-axis. Now, this is the x-axis. Okay, now it's a little confusing because we've got f of x over here on the negative b to a, negative a, but that, see how that must mean that f of x is like this. This is f of x over here because that's the integral we're looking at. And so the right side of the equation is this area here. And now over here, it's a little confusing because I've got f of negative x. But what would that do? That would just take all the stuff from here and it would transfer it over because a negative times a negative would just be a positive to give you the same number again. So what you're going to have is uh, it's not going to be backwards though, because at the a you got to have the same point as the f of x over here. And so it's going to be a mirror image. If I could draw it better, it would be a mirror image. But you see that here's this is f of negative b, which is f of b. Okay, and here's an f of negative x. Okay, so f of x is over here, and it operates on the negative b to negative a interval. And then when you multiply those x values by a negative number, they just become positive, and you get this little picture here. I'll clean it up. I'm just going to clean it up a little bit. Okay, that so that's the picture. Okay, now we have to show that that's the case just using the algebra and the calculus. So we're going to start with one side. Let's start with this side here because so that's the thing I can make a u substitution for. That's the game we've been playing, right? Make the u substitution and then follow your nose. That's the strategy. Okay, now we're going to also use another fact here along the way, and that's this one. This is from page. Where did I find that? It is from page 379. Here we go. I got it. 379, and it's section 5.2 in the book. And it's this fact that the integral from a to b of f of x dx is equal to negative integral from b to a of f of x dx. All right. Okay, so I'm not going to dwell on that too much. We're going to use this fact. I just wanted to show you where I got it in the book. So let's continue. I'm going to start with this integral here, and hopefully we'll arrive at that one. Okay, so integral from a to b of, from a to b of f of negative x dx. Okay, what am I going to do? I'm going to do a u substitution. I'll do u equals negative x, then du equals negative dx. When x equals a, then u will be negative a because I'm taking the x here and I'm plugging it in there to find out what u is. When x is equal to b, then u is equal to negative b for the same reason. I'm going to take the b and I'm going to put it in there, and it's going to tell me what u is. Okay, so now I'm going to set up my integral in u instead of x. So this integral becomes the integral u is going to go from negative b to negative a. The f of negative x part, well, I've called negative x u, so this is f of u. the dx here, well, dx is negative du, because if I solve for it here, now I'll put the du here and I'll put the negative out front. And then using that rule that I just mentioned right here from section 5.2, when you have a negative out in front of the integral, you can switch the bounds of the integral. Okay, so I'm going to do just that. Integral from negative a to no. Okay, and you guys probably saw this already. You're just sitting there like pulling your head wondering why I haven't fixed it. Okay, so u is going from negative a to negative b. I put them in incorrectly. I jumped the gun there because I knew where we were headed. Okay, so let me just fix that. All right. And I'm not going to do that again over here. I'll get better at that. Okay, let's fix it. So I have negative, okay, u is going from negative a to negative b when I set up the integral. So negative a to negative b, f of u du. Now when I switch the bounds of the integral using the negative sign, I get negative b to negative a, f of u du. Okay, and then we use that little hocus pocus trick where we're saying, well, it doesn't matter whether it's u or x or um, Mickey Mouse, then that's negative b to negative a of f of x dx. And that's what we were aiming to show. We wanted to start with this right here and end up with that. That's exactly what we did. Okay, so that takes care of that one. Moving on to number 88. Number 88. All right, again, these are just mental exercises to see if you can play around with the symbolism. And if you can, draw a picture. We'll do both those things here. But all that symbolism is intimidating to look at. And really, it's just training for your brain to absorb this stuff and not really, get overwhelmed by it. All right, so when you first look at it, you should just be like a normal human being and just say, hey, I have no idea what to do. But we're just going to follow our nose after we do a U substitution. And guess what? It's going to work out just fine. That's exactly what's going to get us the result we need. So let's start with this left side here. And we're going to let u equal x plus c. Then du is just dx because the derivative of x is 1 dx and the derivative of the c is 0 because c is a constant. Okay, so then when x is equal to a, then u is equal to a plus c. When x is equal to b, u is equal to b plus c. So the integral in the u form, when I convert it into u, is the integral u is going to start off with a plus c. That'll be the lower bound, and then it goes to b plus c. Then we have f of u, because we've decided that x is equal to x plus c. We're going to put u right here. Okay, and then dx is equal to du. So I'll just put a du here. Well, guess what? That's exactly what we were hoping to get right here in the problem. So this one just fell out right out of the tree. It was a low-hanging fruit. Now we can draw the picture just to kind of see what's going on here if you want to. A little bit because it really just fell out real quickly. So we started off with A to B. And now if we were to add C to both, we have to decide what C is, some length, right? So let's just to make the drawing a little easier, let's make sure C is longer than this interval here. So let's say C is out to here. c. Let's make it a little more aesthetically pleasing. Okay, so this length here is c. All right, so then a plus c would be right here. And then if I took that same length and put it out on the number line, attaching it to the b, I would get out to something like there. Okay, so b plus c. All right, so those are the two intervals, a plus, and then f of x is, go back, so f of x is on the a plus c to b plus c interval. So here's your f of x. And what happens when you do f of x plus c? Well, that moves it, when you have a plus, and if you assume c is positive, which we have in this case, the way I've drawn it, that's going to move it to the left. If you just take a simple case where you have, say, f of x equals, doesn't matter, just do x squared. Okay, so f of x equals x squared is this, and then if I do f of x plus 2, that's x plus 2 squared, and that will have its vertex over at negative 2. So you see how I moved it over to the left. That's just a quick example to show you that when you add inside the function, it moves the function to the left. So when I plug in into f of x, when I plug in a plus c, I'm going to get this point, right? And so when over here at a, if I want that same point, it's going to have to give me a plus c. So what do I have to have there? When I plug in a, I've got to have f of x plus c, so that when I plug in a, I get a plus c, and when I plug in b, I get b plus c. Okay, and I'll get the same graph then. So f of x plus c shifts it over minus c units, or shifts it to the left, c units, if you want to say it that way. Okay, and these are the integrals that we're talking about. Now, one thing I noticed when I was scrolling up here is that I didn't finish this by saying that it's a plus c, b plus c of f of x, because once you switch back to, that's what they asked me to prove, so I got to put it back the way I found it. Okay, all right, let's see if I can get a little neater on the next one. We are almost, I'm going to do one more, and then that'll be the end of the video. Do number 89. Okay, number 89, it says a and b are greater than 0, and we want to show that the integral from 0 to 1 of x to the a 1 minus x to the b is equal to the integral from 0 to 1 of x to the b 1 minus x to the a. All right, well, let's do our trick. Let's start with one side and let's do the u substitution and just see if it just turns out the way we want. Okay, so I'm going to start here, and I'm going to let u equal 1 minus x. Okay, and that means that du is negative dx. And we're going to need to know what x is as well as 1 minus x. So I'm going to glean a little bit of information from what we've done already. This right here tells me that x is equal to 1 minus u. If I solve for x here, I get, put the negative x on the other side and bring the u over. I get x equals 1 minus u. And then I also have dx is equal to minus du. So those are things I'm going to need when I'm making my substitution. I also need to know that when x equals 0, u is equal to 1. When x is equal to 1, u is equal to 0. Because I'm plugging in right here for x to find out what u is. Okay, so putting all that together, I can now write my integral in the form of u. So it's the integral. The first thing is the x here. I've got to have the x to the a. Okay, now the x is 1 minus u. So the first term is 1 minus u to the a. Okay, then I have the 1 minus x to the b term. That's now going to be u to the b, because u is equal to 1 minus x. And then dx, that's equal to negative du. I'll put the du here, and I'll put the negative out front. And then for the bounds of the integral, x was going from 0 to 1. U is going from now 1 to 0. Now, the negative out in front of the integral allows us to switch the bounds of the integral. So that's the same as 0 to 1. 1 minus u to the a, u to the b du. And we know from our previous ones, that's now equal to as if it had an x in it, or a Mickey Mouse. And if we want to really put it the way they wanted it, because they did ask us to show this, well, this is the same, and multiplication is commutative, so we can switch the order of those. It's no problem. That's x to the b, 1 minus x to the a, dx, 0 to 1, which was what we were asked to show at the beginning, right here. Oh, we've done it. Okay. See you in the next video.